And I'll be...
Hello. What's up? I think we're on air.
We're on air?
We're on
live?
air.
Oh
Yeah.
my goodness.
Oh
I
my
always
goodness.
wanted to be on there. Hi, my name is David Silver. I am one of the instructors for the Udacity Self-Driving Car Engineer Nanodegree program.
It's kind of a mouthful.
Car ND.
Yeah, we call it Car ND. And hi, I am Cameron Pittman. I am another instructor in the Car ND. Though you won't see me on camera very much, I'm a little bit more behind the scenes. David is our instructor on camera.
It's my natural charm and good looks.
One of many. Wow, you've got many good things about you.
Mm-hmm.
Yeah, all right.
You do too. All right, so welcome to your first day of class. Cameron will be giving you a rundown of everything you need to know to be a successful student in the Udacity Self-Driving Car Engineer Nanodegree program.
Everything.
Everything. We are really excited for you guys to start today. We have been working on this program for about 8 months now, and a lot of the wrinkles have been ironed out, and you guys are going to get what I think is a really great experience, and what we like to call an only at Udacity experience. You guys are going to learn about how self-driving cars work end-to-end, and in this term you'll learn specifically about deep learning and about computer vision. The projects are really cool. I've been editing a bunch of blog posts that students have been writing about their projects. They've learned a lot. It's been really exciting for them, and it will be even more exciting for you because you won't have to go through all the pain that they went through because they've helped us make it better.
It wasn't pain, but you know, nothing is perfect, right? And so we've made things better over time.
Pain is only weakness leaving the body.
Oh, that's a good quote. Okay,
All right.
So David, you said that I'm going to be giving them a rundown of everything they need to know to be
Everything
you need to know to be a successful student. So I'd say the most important thing is that you go ahead and connect that big, tinfoil thing to your head so that we can just go ahead and manipulate your neurons directly. I think that would be the easiest way. But if you don't have one of those, then let me show you around the Udacity classroom because that's probably a second best thing.
Second best.
All right. Here we go. Sorry guys, I'm gonna just go ahead and share my screen with you so you can see the classroom. Now, which screen do I want to share? David, which screen do I want to share?
Probably a web browser.
Probably not my email.
That
would be kind of funny.
Do you want to close out your
This
email?
one. Let's just do this one.
Let's just do this one. Okay.
Okay, here we go. All right, so to do this, you're going to go to, I think it's just classroom.udacity.com/me, if I'm not mistaken. This should take you to your homepage where you can see all the courses that you are enrolled in on Udacity. And here we go. You'll see a lot on mine because I've got a million things. Towards the top, you should see self-driving car. So yes, you want to continue self-driving car. And by clicking resume learning, that should take you right into the classroom for the self-driving car Nanodegree. All right, so I'm going to actually take a step back. This took me directly into the content, but I want to show you just a quick layout of what you have here. So first off, you will notice that on the left side here we have 3 terms. You all are enrolled in term 1. Now my dates are totally different than your dates because I'm enrolled in, I don't know which one, but I'm enrolled in one of our cohorts. And yes.
I think the screen share, there's a little bit of a lag, but I think it's the screen share didn't go through.
Oh really?
Yeah.
Oh, you know what? I didn't actually click share. I apologize, everyone. Sorry about that. What we've been describing here for a moment doesn't make any sense. Okay, anyway, we're back. I think you guys are watching what we're doing.
So if you go to classroom.udacity.com, that'll take you here.
Yeah,
and
thanks,
you
David.
start in the self-driving car program, and do you want to kind of walk through each of the menu bars maybe?
Sure, I'll go ahead and do that. And I apologize, I swear I know how to use a computer. So on the left side here, this button will take you back to the Udacity homepage. This home button takes you back to your classroom home, which will show you what classes that you're enrolled in and let you jump into those. If you click on this one, this takes you to the course catalog to see all of our many courses. I have no idea how many we have, but we have a lot. This button here with the chat bubbles takes you to the forums. I'll be showing you guys the forums here in just a moment. The forums are used for talking to each other, answering questions, and just generally helping each other out. And then the last thing here is your profile, your Udacity profile, which I believe is also a profile that employers see when they're looking for students to interview and hire. So make sure that you fill that out. Excuse me. And of course, you have settings and logging out at the bottom. So anyway, we are in one of 3 terms right now. We're in term 1. Like I said, my dates here are not the same dates that you'll see. I think I'm in the October cohort, technically, but ignore the dates, you'll have different ones. Term 2 started before term 1, apparently, for me. That's kind of funny. And term 2 will actually be starting pretty soon here, but you guys won't be there for a few months. And then we have term 3. So within term 1, you can scroll down here and see all the lessons in term 1, including the projects. There are many of them, including career services, deep learning, which you guys will be getting to soon. Neural networks. Oh yeah, hey David.
That's me.
David and Ryan. Ryan's another instructor. You'll see him on camera. More deep learning, neural networks, mini flow. You'll be building your own neural network framework, which is pretty fun, building it from scratch actually. And then you'll be getting into TensorFlow, deep neural networks, etc. David's actually going to be going through more of this with you later. But I want to show you how the classroom works once you actually get into the learning side of things. So I'm going to go ahead and click on this button here that says Continue Lesson and Project 1. And this should take us into the actual classroom. So now in the actual classroom, this jumped us in somewhere here in the middle. On the left side, you can see basically the different pages of this lesson. So this lesson is called Finding Lane Lines, which you see here. And this back arrow will take you right back to where we were a moment ago. So I'll just click that, come back in. And then in the classroom here, the main, most important part of the classroom is right here. This big white box where you see videos here. You'll see text. You'll come up to some, here we have some code, some Python. There are also going to be some quizzes. Let me just click on one so you can see what this might look like. In the quiz here, you have some code, so that'll be happening over here. They're going to be a mix of a lot of different types of media, and yeah, this code is live. You can actually run it right here. Let's hope that something happens when I click test. What we're actually doing behind the scenes is we send off your code to a server, which actually runs your code. Here we go. Which actually runs your code and then sends the results back to the classroom. So here's some of the Finding Lane Lines projects. I hope I'm not giving away some of the answer here. I don't know if I've already done this quiz. Ignore the code. It's probably wrong. Oh, you can't see me covering it up with my hand. Anyway, so there's that. Yeah, have a lot of fun here. If you want to give yourself some more room, you can always click on the hamburger icon to give yourself a little bit more room. You can jump around and see what you've done to check marks indicate that you've done things. There's 2 other buttons here. You have a resources button. This is a really great one if you don't have that amazing of an internet connection all the time, because you can actually click on a zip file here and download it and get all the videos from the lesson. So if you want to download all the videos ahead of time and watch them offline, this is a great way to do it. I mean, this is the way to do it. It's not just a great way, it's the only way. Though I have seen some of our videos show up on torrent websites before. I don't know if I should admit that.
Oh my goodness.
I don't know.
Call the FBI.
Call the FBI. Although we do update our videos, so they might be old. It's cool though. I don't really care. Anyway, and then we have a search button here where you can search within the lesson. I believe, actually, I'm not sure the parameters of the search. It might be within the course. Not 100% sure, but there's a search bar there. Have fun playing with it. So that's a quick overview of the classroom. You'll basically be spending all your time here. And so, yeah, have a good time. There are buttons here at the top to navigate. You have a button here at the bottom to navigate forward. And, we put a lot of love into it. The classroom changes all the time. What you're seeing here may not look the same for the next students after your cohort, because we are making changes all the time, new videos, new quizzes, what have you. So it's kind of an evolving experience. So I think that's a pretty good overview. David, did I miss anything?
I don't think you missed a thing. That was perfect.
All right.
So I would love to talk with students, with everyone, about what we're going to cover in term 1, because I think this is really exciting. And from what we hear from students who've been through it, it is really exciting. And so, so we'll kind of cover at a high level what you're going to go through, and then you can dive in right after this and get started. So we're going to start in a module that we call Introduction, and you can see the name of each module here. So this is the Introduction module. And the first lesson in the module is going to be a welcome lesson. So this is going to have this guy welcome you to class. Does anybody on the live chat know this guy's name? Recognize a face? Minor celebrity?
Yeah.
Major celebrity.
He's a nice guy.
Nice guy. This is Sebastian Thrun. Sebastian is the founder of Udacity, and maybe even more importantly for our purposes, he is kind of a legend in the autonomous vehicles world. He won the DARPA Grand Challenge, which was the first big autonomous vehicle race. It was a 100-mile race through the desert in the mid-2000s. He did that when he was a professor at Stanford University. Then he went to Google and started Google's self-driving car project, and they are one of the most advanced, probably the most advanced company in the world in terms of fully autonomous self-driving cars.
Now Waymo.
Now called Waymo. And after that, he started Udacity. And so Sebastian has been a really tight partner of ours in building out this program. He kind of outlined what we should teach, and you're learning from the best. The next lesson, still in the introduction module, is finding lane lines. And in this lesson, you're going to watch a video of a car driving down the highway, and we're going to show you how to take that video and identify the lane lines in the video. You're going to learn some fun things about computer vision, some fun ways to do filtering and transforms of the images. And the idea is to just get started with something really fast and fun and show how quickly you can get to a productive solution with modern computer vision tools. We'll get into a lot more computer vision later, so don't get too stressed about the math or all the details here. This is just kind of a fun start. And if you are excited about the program, this is something you could even get done today. A few hours from now, you could be finding lane lines in your own videos, and it's a pretty neat feeling. It was the first project I did when I was learning to become an autonomous vehicle engineer, and I just thought it was so much fun. I wanted to put it in this program. Then the next lesson is careers. And this is kind of a constant throughout the whole program. After every block or module of self-driving car content, we have a module of careers content where our careers team helps you learn how to prepare yourself to get a job. Now, not every student in this program does want to get a job in autonomous vehicles. Some people are quite happy where they are, and that's great. But if you are interested in changing jobs, we want to help. And so after that, we'll dive into the deep learning module. So we're going to cover a couple of core concepts and a couple of core tools in deep learning. The big core concept is just neural network. So what is a neural network? And we'll talk about how different machine learning tools like regression, or concepts like regression and classification work, and how you can apply something called a neural network, which is a kind of cutting edge computer science tool to solve machine learning problems. As Cameron mentioned, you'll build your own neural network library called MiniFlow. That'll kind of give you a sense of how do neural networks work under the covers. And then you'll use Google's neural network library called TensorFlow to actually build some really big, powerful neural networks to do some really neat tasks. So we'll introduce you to TensorFlow. We'll show you how to build deep neural networks with TensorFlow. Then we'll show you how to build an even more advanced type of neural network called a convolutional neural network. This is a network that's really powerful for images. So you can see in this drawing here, you have something like a kind of relatively flat image, and you kind of take it, oh, I apologize, I didn't mean to click there. By using convolutional neural networks, let me scroll back down to that image. Sorry. By using convolutional neural networks, you can extract what are called the features from that image. So you might start here on the left with a flat image, and by the time you get to the right here, you have a really narrow stack of features, and it might be something like this network, or this image has lane lines, and it has vehicles, and it has trees, and it has sky, and it has a stop sign. And by passing the image through a neural network, you can get all of those features, or through a convolutional neural network. And so we'll teach you about how to use that. And then we get to our first really big project. We have a fun project that you guys can do even today on finding lane lines, but the first really big project is building a traffic sign classifier. And this is a project that requires you to take those convolutional neural networks that we're teaching you about, and you need to figure out how to apply them to classify traffic signs. So if you see a sign on the road, is it a speed limit sign? Is it a stop sign? Is it a yield sign? Is it a construction sign? And by building out these networks to classify traffic signs, you're gonna learn a lot about how to apply neural networks in the real world. Then we're gonna teach you more about neural networks, and we're gonna teach you a different library. So we have been using TensorFlow. At the end of this module, you're gonna learn about a different library called Keras, which is even more powerful in some ways than TensorFlow. And you'll learn some techniques called transfer learning, where you take other networks that other engineers have already trained and you apply them to your own problems. And then you can use that for the final project in the deep learning module, which is called behavioral cloning. And this is a really, really fun project. So behavioral cloning is a project where you drive a car in a simulator. Udacity has a simulator that we've open sourced. And you drive the car like a video game and collect all this data from driving around the track. And you feed that data into your neural network, into a neural network that you build, and train that neural network to drive the car. So by collecting all this data, you can train the neural network, and then the network will drive the car for you around the track. And
that's a cool one.
It's a cool project.
This one's my favorite.
Yeah,
it's a cool feeling when you see your car just drive itself and hopefully not drive straight off the road. That is the challenge.
Drive straight off the road. So actually, with that said, let's go to YouTube. And let's Google some Udacity behavioral cloning videos. Let's see what some students have put up. Udacity behavioral cloning. So let's see, the first video we hit is by George Sung.
This is pretty meta. We're streaming a YouTube video over YouTube Live.
Right. So you can see George, here's our simulator, and there's George's terminal. I'll full screen this.
Does that come through on the live stream if you full screen it?
I don't know, maybe I won't full screen it. So you can see this is George's car driving in the simulator, and you can see in the terminal, this is his deep neural network predicting steering angles and throttle settings based on the images that are coming through from the simulator. So George has already gone through and collected a bunch of data. He's trained his neural network to drive the there, and now the neural network is driving the car. And that's pretty cool. They're actually, almost lost it. There are actually a lot of cutting edge companies out there in Silicon Valley and in other places in the world trying to use exactly this concept of behavioral cloning to drive cars. It's a real challenge. There's more of a traditional robotic stack that people have historically used. It's what Sebastian has used most of his career. That stack involves things like computer vision and sensor fusion and control and path planning. But some people are saying, hey, maybe we can just throw all of our data into a neural network and let the neural network figure it out. So this is really applicable to what's going on at the cutting edge of the field. Yeah,
it's certainly a powerful tool, but as you'll learn later, there are pros and cons to using a neural network, because at the end of the day, it is kind of a giant black box. So the decisions that the neural network makes aren't always readily explainable.
Yeah, so that's true.
It's interesting. It's really cool though. Super powerful, and it's so much fun to watch your car take off. All right.
So let's see, what else do we got? We have, after behavioral cloning, we do job search. We have some more careers lessons, resume review, cover letter review. And then do you want to talk about computer vision?
Sure, although I don't know how much I can say about this. So now we're going back to the world of computer vision, which is actually where you'll be starting in the very first project. And you'll be doing you'll be using some computer vision techniques to pull more information out of the pixels on the screen. As it turns out, this is a pretty fun challenge. As it turns out, there are many different ways of culling information from an image. These involve using different color spaces. These involve looking at what are called gradients, which you'll be learning about soon, to figure out how the colors on screen are changing. and then using that information in different ways to identify different aspects of an image. And of course, doing that over a video stream means that your car can learn about the road. One of the neat things about computer vision is that the outputs of this can actually become the inputs for a neural network. So one of the interesting applications of basically everything that you're learning here is everything is linked together, and so nothing's being learned totally in isolation. And so what you'll have an opportunity to do throughout the computer vision module is at some point you actually can use the deep learning techniques that you previously applied to this computer vision topic as well. So that's pretty fun. Yeah. Let's see, more about getting back into machine learning using classification and taking advantage of an open source library called scikit-learn. That is open source, right? I believe it is. Yeah, scikit-learn to do some more machine learning. David, you wanna take over?
Yeah. So neural networks are one of many tools in machine learning and artificial intelligence. There are other tools that are also used really heavily in the autonomous vehicles world. One tool is called a support vector machine, which is a way of classifying data, and that applies really nicely to computer vision. So you'll be learning how to apply things like support vector machines and decision trees to vehicle detection. And that's going to be the final project of the term for you. And that's going to be where you take another video of a car driving down a highway, but this time you put bounding boxes around all of the other vehicles in the video stream. And that's really cool. When you do that, it kind of starts to feel like, man, you're in a real self-driving car and you're gaining perception about the world around you. And it's a really nice capstone to the term. And then we finish off with some careers lessons to help you get your personal brand ready and your various LinkedIn and GitHub sites ready to go. And after that, it's on to term 2, and you won't be able to see this stuff. You can only see it on Cameron's account because he's an instructor, and some of our beta stuff is up there. Don't pay no attention to that. Don't look behind the curtain. Anyhow, so we've been talking a lot. It's 12:54. There are some other topics we can cover really briefly, like how deadlines work. There'll be due dates for each project as we go through the term. Those due dates are relatively soft. We really encourage you to stick to them because it will help you stay on track and graduate. But the only hard deadline is the end of term deadline for passing all your projects. So by the end of the term, you have to have passed all the projects, and then you can move on to term 2. We have some terrific hiring partners who partner with our careers team. We can actually go to the Nanodegree. You can go to udacity.com/drive and see where our hiring partners are. We have them in the US, in Europe, in various parts of Asia, in lots and lots of different places in the world, and they are really excited about hiring Udacity students to work on autonomous vehicles. So we want to help you get a job at some of those partners if that's something that excites you. So that's a lot of us talking, and we should stop. What questions do we have that we should tackle?
Yeah, no, that's a good question. Let's see. I'm looking through the chat list now. Let's see. I see one question here. Let's see. Elizabeth, could you help us out here? What should we answer? Oh, you're not listening to us. Okay, let's see. Hiring partners, large goal. Okay, here's a good question. Let's see. Mark is asking, a large goal is to complete an open source self-driving car. Are there any problems that we should tackle specifically? And that's a great question. Do you want to answer that one?
Yeah. So a big goal of this program is to help students put their code on a real self-driving car at the end of the course. That will come in term 3. And so if as you learn about deep learning and computer vision and sensor fusion, localization and control all the way through terms 1 and 2, in term 3, we have an actual self-driving car that you're going to learn how to put code on. There's a separate project we have running kind of outside of the Nanodegree program that involves building this open source self-driving car. And our colleague Oliver and some of his teammates are working on that together with a whole community of students in the nd013.slack.com channel or Slack community. And so if you're interested in working on the open source self-driving car alongside the self-driving car Nanodegree program content, we encourage you to go check that out in the open source self-driving car Slack community. And a lot of what we're going to be doing here is going to prepare you to contribute to that program.
Definitely, definitely. Let's see. There's another one here. We have a question about mentors. We have a few questions about mentors. I'll let you do that one.
Yeah. So in your classroom, you should see a button in the lower right-hand corner that allows you to contact your mentor. Every student in the program has a mentor. A mentor has about 20 students. Mentors are located all around the world, so they may not be in your specific time zone, but they will get back to you within a maximum of 12 hours if you have a question or need some help. Our mentors, their main goal is to help you be successful in the program. They may not know the answer to every single technical question you have, but they will help you find the answer. So they'll point you in direction of the forum category where you should post a question, or they may know the answer off the top of their head, or they may work with you on Slack to try and figure out who can answer a question for you. This is a really important part of the self-driving car experience, and most of our students find it really, really valuable, and we hope you do too.
Yeah. Oh, that's great. Great point. Let's see. We have 2 minutes left. Let's see if we can answer some of these really quickly. We have a question about is the self-driving car Nanodegree self-contained? The answer to that is pretty much yes, pretty much, although not entirely. We know that some people do like using Andrew Ng's course. Was it CS231N, the Stanford course on neural networks?
Andre Karpathy.
Yeah, oh, sorry, Andre Karpathy's course. People found that really helpful, so that's cool. We encourage you to use outside resources. You may find later on, especially in term 2, we'll be getting into C++. So if you aren't already an expert in C++, it'll probably help to brush up on that. Did you elbow me for a reason?
No.
Okay, sorry. Anyway, we're working on a course there, but it may not be ready by the time you guys are there. So we're working on it. And I think that's kind of it. For the most part, it is fairly self-contained. Although we do always encourage you to extend your learning if you find something that's super interesting. We have other courses on computer vision and AI and deep learning on our site, and so as these are all topics that you'll need, or you might find that you like them, so feel free to dive in deeper. Let's see. There's another question here. Are there any other fields where you can apply the knowledge that you're learning besides self-driving cars? I mean, yes, absolutely. Self-driving cars are basically robots with 4 wheels. So any kind of robotics, any kind of field that's going to apply machine learning, which is going to be more and more fields every day because it's a technique that can be used basically everywhere. Yeah, you can absolutely apply those what you're learning there.
I have a question.
Yes.
So we had some pre-submitted questions, so I'll share one of them now. I don't know if we already talked about the topic of the difference between artificial intelligence Nanodegree and the self-driving car Nanodegree. So this question is from Sandeep. In terms of artificial intelligence content, how much does this program differ from the artificial intelligence Nanodegree?
So the question is, if you guys can hear that, is how much does the artificial intelligence Nanodegree's content differ from the self-driving cars content? I'm gonna give that one to you.
Okay. So the self-driving car Nanodegree program is laser focused on autonomous vehicles and helping students learn what they need to know in order to get a job in the autonomous vehicles industry. In order to do that, you're going to learn a lot about machine learning, deep learning, robotics, and embedded software. However, the artificial intelligence Nanodegree program is a little more focused on general tools that you can use in a wide variety of disciplines. So it's a little bit of what a designer might call a kind of strength versus flexibility trade-off. The self-driving car program is not so flexible. We are laser focused on autonomous vehicles, but we are really, really strong in that area. The artificial intelligence Nanodegree program is super flexible. There are a lot of places you can use artificial intelligence tools, and they'll be teaching you a lot of different tools that that you can apply wherever you are. They're a little less laser focused on any one area.
Let's see. Oh, there's a question. Can we repeat the name of the course that was suggested? CS231 on Stanford. I think that was the one.
CS231N by Andre Carpathy, Justin Johnson, and Feifei Li.
All right.
231. I just typed it in.
Oh, thank you. Elizabeth, were there any other questions?
Yeah, let's see. So this is a common question I actually see when students are starting, even though they've already been accepted. I have one from Jay Raj. What are the prerequisites? What if I'm not able to complete the prerequisites before starting?
Yeah, so the prerequisites for the self-driving car nanodegree program are intermediate programming ability, ideally in Python, because that's the language you'll be using in the course, but other languages, if you're a solid software engineer, you should be able to pick up Python pretty quickly. Basic linear algebra, so basically matrix multiplication, basic calculus, so derivatives and integrals.
Differential equations will be helpful.
Differential equations will be helpful, particularly later in the course, but will kind of help you get through that if you at least understand derivatives and integrals.
Mm-hmm.
That'll be enough for now.
And well, the question is, what if students don't finish all the prereqs before the term starts?
Right. And so then the last prerequisite is statistics, so probability of distributions, means, and standard deviations. And so if you're not familiar with those topics, you might want to consider spending a month brushing up on those topics. There are a variety of resources that we point to on our homepage at udacity.com/drive. And you can come back and start with the March cohort. Those are kind of core topics that you probably are going to need to know in order to be successful in the self-driving car program. I mean, ideally, through the application process, we've selected folks who have those prerequisites. If you feel like you're totally lacking, then you can defer and come back in a month or two after you've had time to brush up on those prerequisites. If you feel like maybe you're just a little bit weaker than you'd like in, say, statistics, you can hustle and do some extra learning on the side to make sure you're up to the level that you need to be.
Mm-hmm. I hate to admit it, I'm the kind of learner who waits till I absolutely need to learn something, and then I go off and learn it, and then I come back. Yeah. Yeah. You don't have to be like me.
Don't be like Cameron.
All right, let's see. There's some other questions here. Let's see. There was a question about something earlier here. Anyway, okay, let's see. Hiring partners hiring globally. David, do the hiring partners hire globally?
Yes. So we have a number of hiring partners who have been explicit that they want to find the best engineers that they can identify no matter where they are in the world. We also have hiring partners who say, we exist in a certain geographic area and we want to mainly hire from folks who are already in our geographic area. So it's a mix, but we definitely have hiring partners, particularly at larger companies, who are both looking to find people anywhere in the world and bring those people to their offices. And we have big hiring partners, big automotive suppliers, big automotive manufacturers, companies like Mercedes-Benz and Bosch and BMW, who have offices all around the world. And so they, have an office in China, and that's a great place to apply if China is where you live right now. And they have offices in Germany, in the United States, and India. And so we have hiring partners who kind of fill both camps. They're hiring worldwide to come to them, and they are hiring for various office locations worldwide.
Yeah. No, it's a big world out there, and self-driving cars aren't just happening in any specific place. Let's see. I see another question here about a computer setup needed for the project. Oh, and I did see some people saying they're having a hard time finding the mentor button. I guess we'll look into that. We can't really debug that while we're doing the screen doing this, but we'll get back to you guys on that. Keep an eye on it. So let's see. What's a computer setup needed? So I'll answer this one. You're okay on any operating system. You can Mac, Linux, or Windows. I will say that. Let's see, with TensorFlow in particular, it only recently started being natively supported. I don't know if native is the right word, but they officially supported on Windows. So you may run into some issues there. You will find that you may have a slightly easier time if you're using Mac or Linux generally, but you should be able to get away with anything. In terms of hardware, the only real big bottleneck for hardware will be training your neural network. in which case you want basically the biggest GPU possible. Of course, those are also very expensive. So we do offer AWS credits, right? We're still doing that?
Yeah. We're still doing that.
So you'll get some credits for AWS. You'll be able to spin up a GPU instance with a much larger graphics card than what most people have, and run your neural networks much faster there. But you know, it's still not necessarily an ideal situation, but you can definitely get away with it in terms of what we're doing just for the Nanodegree, right? And then for software, I think the only thing you need, I mean, we'll be linking to you all the open source projects and libraries and frameworks as you need them. Besides that, you know, just have a favorite code editor. I think that should be good. And a terminal. Yeah, if you're on Windows, you'll probably make your life much easier if you do use the new Bash on Windows.
Cool.
I think that answers it. Did I miss anything?
The one other thing, and this is, we point to the Udacity CAR-ND Term 1 Starter Kit during the course, so you'll see that pretty early on. There's a little toolbox that we give you that sets up all of the different programming environments and libraries and packages that you'll need. You don't have to use that, but it will make your life easier probably if you do, so feel free to use it.
Good, yeah. Let's see, I see a question here. Are video lessons available in some form of text format? That's a great question. We do have transcripts in almost all the videos, which I believe are downloadable, or at least, sorry, excuse me, subtitles for the videos, which are downloadable, if I'm not mistaken.
Mm-hmm.
Let's see. There's another question here. I want to see. AWS, you need help with the setup. There will be instructions, and you can find, you can find so much help for using AWS online. It's such a popular technology, so any quick Google search can definitely answer like 99% of the questions you're going to have starting off. Let's see. Anything else? Elizabeth, did we miss anything?
Let's see if there's any leftover questions. I think we've kind of hit pretty much almost everything.
Okay,
I'm sure there's many other questions.
Yeah, let's see. I see a good one here. Scrolling up a little bit. The question is, are there any meetups for students? I would say, yeah, sometimes. As far as I know, we aren't organizing any. Am I wrong?
We ourselves do not organize regular meetups for the self-driving car program, but there are a lot of study groups. And some of them meet virtually, some of them meet in person. A great place to learn about this is the student Slack channel that many of you may already have logged into. It's at carnd.slack.com. It's limited to only self-driving car students. And as a student, you now have access to that. And there are a ton of students in there who have already gone through parts of the Nanodegree and are excited to help you proceed through the Nanodegree yourself, and who have organized study groups that you can meet with to help you along the way. And if you happen to live in a place that doesn't have a study group and you would like to have one, then you should organize it. There's a lot of stuff that happens in this course that is student driven. We try and facilitate all kinds of things, but we're not as smart as you. And so a lot of times you guys think about things that we miss, and go for it. And if there's anything we can do to be helpful, please let us know.
Definitely.
You can email me at david.silver@udacity.com, and you can just show up at Cameron's house and ring the doorbell at 2 in the morning.
No.
Do it.
No.
Do it.
That is just not an option. Let's see. Here we go. Here's an interesting one. We have a question here about why is this a 9-month course as compared to the other Nanodegrees, which are run on basically a monthly basis. You want to answer this one, or you want me to wing it?
Because we're awesome.
Because we're awesome.
It's a 9-month program because we talked to a lot of hiring partners before we launched the program, and they helped us build out the course. And we said, what do students need to know in order to be great candidates for jobs at your company? And the curriculum that we put together in terms of having an introduction, and then deep learning and computer vision, and then sensor fusion and localization and control, and then systems integration, and an elective month where you can go deep in an area, and finally well, it's path planning, then an elective, then systems integration. That's the curriculum that hiring partners help put together for us. And so it's really driven by our goal to help you get jobs in the industry.
Mm-hmm. Yeah, I think it's cool. It's kind of nice. It feels good. I like it. I've been involved in both kinds of Nanodegree, so I'm enjoying it. Let's see, another question. Will the content be available in the Udacity app sometime soon? I'm assuming that's the mobile app. Last I heard, it's being worked on, but I have no idea what the timeline is. Hopefully as soon as possible.
They promised me early January, and then Apple did something and caused a lot of problems. Not for us specifically, but our mobile team wound up having to put out some fires, and things got pushed back. But that is a good reminder for me to stomp over to our mobile team and say, can you please put our course into the app?
Yeah, it's, anyway, that is, let's see. Okay, let's see what else we have. We have, I see a question here. How do you, this is kind of an interesting one. How do you plan to involve the overseas students with the hiring partners? I think, we have a lot of interest in, getting hired. Can't blame people.
Mm-hmm.
I think the start of this answer is that, the first thing you need to do is make your profile, make sure that it's up to date. As you'll be working through the Nanodegree, you'll be building these projects that you want to show off, and our profiles let you show off your amazing projects. And so just by building that profile, our hiring partners will have access to you. Beyond that, David, what else are we doing here? We have some things planned, right?
We have some fun things in the pipeline. So Udacity is focusing more and more on helping to put students into jobs. Udacity is always focused on that, but particularly with self-driving car, we've seen a huge demand from employers for Udacity students. And so we're investing in things like a recruiter who now works at Udacity, and his entire job is to help put self-driving car students or match self-driving car students with companies that want to hire them. And so throughout the Nanodegree, we'll be asking you, are you looking for a job? If you're not, that's totally fine. But if you are, we're going to ask you, what companies are you interested in working for? Where are you interested in working? Where are you legally authorized to work? What subjects are you interested in working on? And using that information, we are going to match you with specific companies who are a good fit for you. And at that point, it does become a relationship between you and the company. The company wants to interview you and see if you're a good fit, but we are doing everything we can to make the best matches so that you have the best chance of getting a job in the industry, if that's what your goal is.
Mm-hmm. Cool. Let's see, we have some others. Let's see, self-driving car graduates in Blitz, maybe. I'm gonna say hard maybe on that one.
Christian, our Blitz head, has told me that there are a few projects in the pipeline that might, so Blitz, we should step back and say, Blitz is a Udacity program where Udacity Nanodegree graduates work as contractors for outside projects. And so Udacity will hear from someone that, hey, we want to build a self-driving car. Can Udacity students do it? And a bunch of Udacity students will get hired by our Blitz team and put on the self-driving car project. The Blitz projects so far have mostly been mobile and web-based, but Christian, our head of our Blitz product, has told me he has a few potential projects in the pipeline that are related to self-driving cars, and so you may see some of that coming down the pike.
So maybe.
It was a long way of saying maybe. I should have just stuck with Cameron.
No, it's good. I think it's better. It's better to be clear. Let's see. Classes, Connect, classes, percentages. Docker. Do we use Docker? No. Or do we? Am I wrong?
Yes. So if as you go through the course, you'll learn about the Udacity Car ND Term 1 Starter Kit. I mentioned that earlier. There's a page on GitHub. If you want to just Google it now, you can find it pretty easily. And there are two ways you can get started using the core Udacity or the core software packages that you need for this course. The way we recommend is Anaconda, which is a Python environment manager. And we have all the files set up, so you just have to run a few commands and your environment will get set up with all the tools you need. If for one reason or another the Anaconda environment doesn't work or you would prefer not to use it, you can use Docker, which is a virtual machine platform to launch a virtual machine on your computer that will give you the Udacity software packages. Cool. So we recommend Anaconda, but you can use Docker if that's better for you.
I didn't realize. Okay, let's see. How many students have been hired? Now, this question is how many previous students have been hired through hiring partners. I'm assuming we're just talking CAR here. I have no idea what the numbers are, but though I do know that employers have at least been talking / interviewing people, right? Yeah, we have a number of students interviewing. We have several students who have started on contract roles, internships. We actually need to do a little bit better of a job tracking in one place all of the students who've gotten hired. This is a little bit tricky because there's no law that says if a student gets hired by an automotive company that they have to come back to Udacity and tell us that it happened. So we are working on measuring that a little better. I do know that I was in the offices of our partner at Mercedes-Benz yesterday, meeting with them, and I looked out at the conference room and some random Mercedes-Benz engineer was taking the Udacity self-driving car Nanodegree and driving the car around the simulator on his machine, and I was really, really excited to see that. He was really, really excited. He's not exaggerating. Really I don't think I've ever seen you that excited, except for maybe that time you had an ice cream bar with coffee yesterday. Yeah, he tweeted. I should not have called the guy a random engineer. He was a very nice Mercedes-Benz engineer. He was not a random engineer. But it was exciting to see that from someone that we didn't otherwise know at Mercedes-Benz. The Mercedes-Benz folks are world-class in terms of autonomous vehicle engineering, but everybody has things that they can learn. I certainly do. And it was exciting that for some of the things that this particular engineer wanted to learn, he could learn them from us. Mm-hmm. Let's see, here's another question. Is there a good resource to read about the hardware that's going into our car? I don't know if that's aggregated anywhere because the hardware is changing constantly. I see new pieces of hardware appearing and disappearing on the car all the time. So I'm gonna say no. However, if you do pay attention to, in the ND013 Slack channel, Oliver posts the challenges for students, and I believe there is also an actual website for that. I think it's like udacity.com/open source self-driving car, something along those lines. If you Google Udacity open source self-driving car, it should show up. For all the challenges, if hardware is involved, the team actually lists out exactly what hardware is involved and what you, as somebody participating in the challenge, would get from that hardware. Okay, so let's see another question about being involved in the open source self-driving car project after you graduate. I believe so. I don't see why not. Yeah. Yeah, that team is constantly looking for folks to help with the open source self-driving car. So, so whether you're a prospective student or a current student or an alumna, I encourage you to join us in the nd013.slack.com community and work on that open source self-driving car. All right, let's see another question. I'm gonna answer this one in one word. The question is, do you think that future jobs will require knowledge of interdisciplinary skills? I'm gonna say yes, absolutely, 100%. Learn as many skills as you can because you need all of them. All the skills, just learn all the skills, every skill that's ever existed. I'm being sarcastic, but yes, you should. Let's see, here we go. No background in, have you seen people with no background in software development get hired as a self-driving car engineer? No, we have not. Sorry, I'm assuming here, I read that as no background as in you don't know how to code, not you've never had a software development job. Having a software development job is probably not a prerequisite, but you absolutely need to be professional at writing code. So I think that's more of the prerequisite than anything else, I think. Does that sound right? Yeah, almost any company that's hiring autonomous vehicle engineers nowadays will tell you that they are not hiring pedigrees, they're hiring people who have skills. So the question is, do you have the skills to contribute on the team? Mm-hmm. Let's see, another question. Google Cloud has GPU instances, or we're going to be giving those out? Probably not. I don't think we have any of those. Or do we? No, not currently. We have talked to a number of providers of cloud GPU services or cloud machine learning services. And we, for the moment, focus on AWS
and they're GPU-enabled EC2 instances, and every student in this cohort will get $50 worth of credit through AWS Educate to use to launch GPU instances and train their neural networks. There are other services like Google Cloud that offer different types of products to accomplish something similar. We are considering incorporating some of those. It does start to get confusing if we say you can do this or that or that. So we try and streamline a little bit, but we also want the best solution for you. So it's something we're weighing.
Yeah. Let's see. Questions about setting up an environment. I'd say a mentor is a good person to ask. The forums. And then my favorite is Google. Google can help you out with environments. It certainly does get tricky, especially when you have, let's say, a Windows setup, or if you're not too familiar with, let's say, like the Linux path or the Unix path or something along those lines. But other people, your classmates, can definitely be a big help there. So Google around, see what you can find out. Copying and pasting error messages into Google is your friend. Yeah. That's like how I solve 99% of my problems.
I should also stress the importance of the Slack community. I don't have the Slack community up in front of me, but my guess is that there is a channel on setting up your environment. I think it might be called SDC-environments or something like that. So if you check out the student Slack community, there are channels for kind of each of these topics, and it's a really good place to go if you have a question about a specific topic.
Okay. All right, here is a speculative question.
Speculative.
Yeah, I like this one. Here we go. So do we think that self-driving car tech is going to be sold as an add-on to older cars or just integrated into newer cars? Can you answer? I'm going to challenge you to answer in 2.5 sentences. 3 sentences. You have 3 sentences to answer. Go.
Mostly in newer cars, sometimes as an add-on.
Sometimes as an add-on.
1 sentence.
That was good. That was good.
It was a
hyphen.
It was a compound sentence.
Yeah, that's okay, but it counts. Let's see. What's a good replacement for the NVIDIA PX2? I have no idea. And those are like what, like $10,000, $15,000, something like that. So maybe buying a couple of Titan X's and hooking those up over SLI.
I was when I worked at Ford Motor Company, I was on the hardware platforms team, and so this is a topic that's near and dear to my heart. The Drive PX2 is an incredibly powerful machine. NVIDIA is coming out with a new platform, I believe at the end of this year or early 2018, that I guess would be a good replacement for the Drive PX2, but for now it is NVIDIA's state-of-the-art product for automotive software development. But there are other platforms out there by other manufacturers, CPUs, GPUs, FPGAs, combinations of them that are put together. So I wouldn't hazard a guess as to what's better than the Drive PX2, but the Drive PX2 is a great platform.
Yeah, it's certainly an option. Let's see, here's a question about projects. Let's get back to the lessons. Here we go. If the projects work as per the requirement, will the code be assessed again for the optimization? Or basically for performance, it sounds like it's asking. This question's asking. So the answer to that is, every project has a detailed rubric associated with it, and the rubric says exactly how to be evaluated. In some cases, performance is very important, and that's going to be a rubric item. You'll see that there. In other cases, it's not, and it won't show up in the rubric. I mean, generally, so I can tell you right now, I'm actually working on the rubric for a project in sensor fusion, and we had a long discussion about, all right, so how much should we be evaluating for execution speed? As it turns out, speed and performance at the expense of, say, safety or security is not a good thing. So that isn't always the goal. For the most part, actually, what you'll find with these projects is we really want to make sure that you have the general algorithms down and that you are expressing yourself well in code and you're not optimizing for every single CPU cycle. That's not important at this time. There are all sorts of techniques for squeezing every bit of juice out of a piece of hardware, and you don't have to worry about that yet. So I guess that's the good news. Let's see, David, I've been asking all the questions. Why don't you take this one?
Okay, this is from Nikolay Angelov, and it is, what do you
Oh, sorry, I scrolled.
What do you think is the most popular, or is most proper RTOS for self-driving car development? So this is a question about what type of middleware should a self-driving car use? So one of the challenges if you're building a self-driving car is how to communicate between all the different sensors on the car and all the actuators. Those are the motors that increase the throttle or hit the brake or steer the car, and having a software layer, a middleware layer that kind of handles all of that can be quite a challenge. A really popular open source version is ROS, that's Robot Operating System. It's a little bit of a misnomer because it's not actually an operating system, it's a middleware layer, but it is kind of the big open source operating or middleware platform for autonomous vehicles. But there are a number of commercial platforms as well. NVIDIA has one called DriveWorks. Our partners at Electrobit have a similar platform called Robinos, and there are other similar platforms too. A lot of companies are working on figuring out, what the right platform for them is. Almost every company that I've talked to is using something a little bit different or something they've kind of custom built themselves. And so whether an open source version will win out or a commercial version, I don't think is clear yet.
Cool. Let's see, I see a few questions. We're coming down to the end. I see a few questions here. People are asking about their personal chances of getting a job based on their backgrounds. And I'll say everybody's different. Having a background in something related to self-driving cars certainly helps, right? There's no reason that wouldn't be a good thing. But I think at the end of the day, right, this is all skill-based. So if you're, even with an amazing pedigree, if you show up to an interview and you can hardly write a function in C++, that's not going to help. So, at the end of the day, it's all about the skills that you gain. Speaking of C++, we have a question here. I'm going to get to this one. It says, Christian asks, how much C++ experience is needed for the second term? The good news is, not much. You will be writing your code in C++, starting a couple lessons into the second term. However, the code that you'll be writing actually will look quite a bit like the Python that you've written in the past, especially if you've taken the AI for Robotics course. So let's see, the C++ you'll need definitely basic control flow. You'll need to be able to instantiate classes or instantiate objects from classes, with header files, dealing with public and private members. I think, honestly, though, the most complicated thing is there are a handful of references, and that's basically it. A handful of pointers that you might have to dereference at one point or another. But that's basically it. We'll be using CMake to deal with compiling, because CMake is cross-platform. You don't need to worry about using, let's say, Eclipse or Xcode or anything proprietary to compile your code. So that's the good news there. So if you can get through, call it the first couple chapters of a general introduction to C++ book. My favorite, the one that I used, is the C++ primer. I got like halfway through it, and I think I know way more C++ than I need just to even teach this. So you should be in good shape. You don't need to stress too much. Let's see, and I think we're at time here. David, is there anything else that you want to go over before we? Any other questions you think they should be asking?
I certainly wouldn't presume to know what you should be asking, but I'm happy to answer questions. Elizabeth, should we keep going or should we wrap it up?
We should wrap. Yeah, we're right at the hour mark, so we'll wrap it up now. But yeah, we'll be in Slack throughout the week.
Okay. So I don't know if you can hear Elizabeth in the background here. So our community manager Elizabeth, who's amazing and helps us organize all these. Yeah, we'll be on Slack pretty much constantly. David, like he said, he's available 24/7. You can just knock on his door. He'll be there for you. But no, david.silver@udacity.com. We have Slack. We have forums. We have mentors, definitely, although I know you guys are saying that you're having problems there. I promise it'll be working. We'll be getting to you about that if we're still having issues. And then, of course, the fourth option are carrier pigeons. We actually have a roost on the roof. Feel free to send it. That was a joke. Terrible joke. I've been watching too much Game of Thrones. Okay. I think we're going to wrap this up. Yeah,
we are really, really excited.
We are.
Thanks so much for enrolling. I think it's going to be a lot of fun, and we are really looking forward to helping you guys get jobs.
Yeah. So we'll see you guys online. Take care.
So pull up the hangout.
Oh, sorry. No, we have to figure out. Oh, here we go. Bye.